Hello, good morning everyone, and welcome to our session on machine learning. In this session, we are going to discuss about data engineering. Data engineering is a term which is nowadays often used in place of ETL or ELT. Traditionally, the term was ETL, extract, transform, and load. What it was used for? ETL was used for extracting data from data source. The data source is typically an OLTP system from where we extract data, transform the data, basically do the necessary data manipulation, and load that transformed data in a data mart or a data warehouse. Now, with big data, we call it data lake. And this data warehouse or data lake is then used for various purposes like reporting, dashboard, predictive analytics, and so forth. So we are going to discuss in this session the concepts revolving around data engineering or data ETL. So welcome all of you, and let's get started. Before I explain the concepts related to ETL, I want to explain a high level framework application of ETL. With this application, you will be able to visualize the importance of data engineering. I'm taking a banking example. The reason I'm taking banking example because most of us would already be having some account with a bank. So we will be able to better understand the application of ETL. Imagine yourself as a customer. Now, as a customer, you have got various touch points like a branch, or you can talk to the relationship manager, or you can withdraw money from an ATM. You can do fund transfer through net banking, mobile banking, phone banking. Nowadays, wallets are also extensively being used. Email, SMS channels can be used to register your complaints, or SMS shortcode can be used to check balance in your account and so forth. And social media, Twitter, Facebook is often used by customers for expressing their opinion, and especially Twitter is become like open source CRM where most of the customer went out their anger or their displeasure related to services. So there are various touch points through which a customer today has interaction with the bank. Now, when the customer does a ATM transaction or goes to a branch and does a transaction, for the various product or services that he has, he may go to a branch for depositing money in his deposit account, or he may have a loan account or a credit card or investment account, insurance, some value added services. So various products and services for which the customer through the touch point does transaction. Any transaction done by the customer is saved in the core banking system. At a high level, we can use the term OLTP. OLTP stands for Online Transaction Processing System. The OLTP system is not restricted just for banking domain. OLTP is a generic term which is used for any transaction processing system. For example, you are a telecom customer. When you do calls, the call data is stored in a transaction system, and that data has to be stored efficiently and very quickly. So those kind of design where we enable quick transactions to be inserted, updated, deleted are called OLTP. And the OLTP for banking is typically called a core banking system. And if you have some customer complaints and so forth, you may have a CRM system also. So all the data of a bank goes either in a core banking or a CRM or some other systems specifically designed for the products and services which the bank provides you. Now, this is how the customer interacts. Now comes the ETL or the data engineering aspect. The data which is stored in a OLTP system is optimized for doing insert queries, update queries, and delete queries. From a SQL standpoint, the OLTP system is designed for fast transaction processing, which involves insert, update, delete. However, there is one more important requirement, which is reporting. And for reporting, we need to fetch information from the database. And that's where we require select queries. The OLTP is not optimized from a select perspective. So what we do, we on a periodic basis, the periodicity is typically daily, end of the day. In certain scenarios, the periodicity may be every second, every minute, depending upon the requirement. However, in most of the scenarios, the periodicity at which we take data from these systems on a daily basis. So what we need to do is pull out data from these systems. Pulling out data means extract. E for extract. Now, as we pull this data, and if it's directly dump in another database as it is, then it would be simply backup. Now, if we take the data from a table and simply put as it is in another database, then it is as good as backup. That we can do using data backup of database system. However, our objective is not just extract, but to store data in a format such that we can get our reports, dashboards, and on top of which we can do lots of analytics easily. So this data which we have coming from the source system needs to be probably be transformed and then loaded in a warehouse. And this is where the ETL word comes up. And as I said, nowadays, the terminology which is often used instead of ETL is data engineering. Now, whatever the terminology might be, end of day, the concepts remain same. You have to extract data, do transformation, and load in a warehouse. So the data that you can do is will go in a, you may call it as a data warehouse, or you may call it data lake, depending upon whether you're using a big data technology. Okay, then we call it data lake. This data is stored in a design. This was the original data was in a design which is OLTP. The data which is stored in a warehouse, the design is OLAP, online analytical processing. Okay, this analytical processing means I should be able to get reports and dashboards very quickly from the warehouse. I should be able to do analytics, predictive analytics, use machine learning on that data easily. So those are the applications, and the design to be followed is OLAP design. I'm not in this part of the session, I'm not going to get into OLAP design and OLTP design. For OLTP OLAP, you may have to watch my other recorded videos. Okay. However, let's move forward. One of the thing that the warehouse does is to give you a 360-degree perspective of the customer. When you fetch data from the existing systems, the data from existing systems will be basically your customer details, the products and services that the customer has already purchased from you, and the transactions that the customer is doing using those product or services. So this customer details is a static information. It forms 90-degree perspective. The product services, the existing relationship is another 90-degree. The transactions, the behavior the customer shows on existing product and services forms another 90-degree. All of that you summarize and store in your data warehouse, and probably one of the output of a data warehouse is analytical ready data mart. It gives you 270-degree perspective. This 270-degree perspective, if you put through a predictive engine, basically as a data scientist, you will build models on this data, and using predictive engine, the data will go to the predictive engine and the data will be pushed back into this. Basically, whatever the output of the predictive models again has to be stored here, and that gives you another 90-degree, which I have shown here. This additional 90-degree is predicting the future behavior of the customer. That makes 360-degree view. Now this 360-degree view, where we are now predicting the future behavior, what we can predict as part of the future behavior, what other products we can sell to the customer, that is cross-selling. We can predict on existing customer, on existing products, which customer can be upsold. Basically, we can move the customer to a higher premium product. Some customers we may probably want to down migrate. There are many channels. We may want to move the customers to low cost transacting channels. We may want to find out customers who are likely to churn from the system. And there are many other objectives which can be served. And this entire 90-degree perspective of predicting the future behavior, taken together with the 270-degree perspective of what customer has already purchased and what is the behavior on that, forms your 360-degree view. Now, if you would not have done this ETL step, then building this predictive layer and finding out potential to cross-sell, upsell, down migrate. Here we are talking only from a marketing standpoint. However, please note, this data can also be used for risk management, because you have the behavior of the customer. So this is not restricted only to marketing opportunities. this analytical ready data mart is also useful from risk management perspective. Okay, because that also forms the behavior of the customer. With this high level objective, I hope you understand the importance of data engineering. I have tried to explain the data engineering from a banking perspective, but this is not restricted only to banking domain. It applies to all industries. Now, having explained what is the application of ETL, why ETL data engineering is very important, now let's move on to understanding what is ETL. In the previous slide, I have already explained this. However, let's go forward. Once again, try to understand the ETL concept. As an organization, you will have data residing in your OLTP system, which may be ERP, CRMs, databases, or sometimes you may get data from a file-based system, and sometimes you may have data coming from web where you are doing web scraping. Okay, so the point is there is something called data source. The first thing is there has to be a source from where you need to extract. The data which is in the source, as you can see, is stored in many different systems. So we typically use the term disparate source systems, meaning that the data is residing in many different source systems, and in the many different source systems the data may be, here there is a customer C1, and this customer C1, some information is there in this ERP system. The same data of this customer C1 may be in some CRM system. The same information of this customer may be in a database, some OLTP system, and there may be some data which is in a file based system. So basically the point is the information about a given customer may be available in multiple tables, multiple files in the source systems. I want to get a unique perspective, single view perspective of this customer, and that's where we need to do ETL, extract, transform, load, and then we put that data in a warehouse. A warehouse may have many data marts. What is the difference between a warehouse and a data mart? If I am creating a data which is, I'm aggregating the entire data from a particular functional department perspective. For example, if I have this data stored, aggregated from a sales department perspective. So the objective is I need to pull out many reports for the sales department. So the design and the storage of the data would be optimized for the sales department. And when the data is optimized and stored with a perspective for a particular functional department, we call it a data mart. Then you may have the same data being stored and optimized for product department. Then it becomes a product data mart. You may have the same data stored and optimized for reporting and dashboarding for channel management department. So it becomes a channel data mart. So a warehouse can have many data marts which are optimized specifically for a functional department. Okay, and as you can see, these data marts are used for reporting, ad hoc analysis, OLAP analysis, and here you can also put one more arrow and say data scientists who will be using this data for model development. These reports will go to the business users. These ad hoc reporting would be asked by business users. These OLAP analysis using tools like Tableau, ClickView, again will go to business users and so forth, right? So that's what ETL is. The same ETL, now instead of saying ETL, I'll use the word data engineering. Now if you use the term data engineering, typically in a ETL, the way things are represented is by arrow marks. However, now when we use the term data engineering, we use a term called data pipeline. There has to be, if you are coming up with a new terminology, you need to come up with a new terminology to replace the old terminology ETL. So in data engineering, the terminology used is data pipeline. The thing remains same. Only thing is change of the terminologies. The concept remains same. There is a data sources. You may have a data sources which may be database, SQL, NoSQL. You may have a file system, CSV file, XML file, JSON, HDFS, or you may be extracting data from website, web scraping. Okay. When you extract data, you create a pipeline. And typically what happens is the data which you extract, you directly don't put in the warehouse. Okay. There may be a data base coming in between, which is typically called staging area. We'll learn about what is staging and more. So typically what happens is you extract data and first push the data as is in a staging. And here you do the transformation. So here this part of the pipeline is extract. The data comes in the staging area. Here you do the transformation. And after doing the transformation, you push the data in your data lake or the data warehouse, whatever you name it. Okay. You push the transform data, that is load the data in the data warehouse or the data lake. So again, it's the same concept, ETL concept. In the ETL also we have the staging area. I might have not shown here, but staging area exists. Even in the data engineering, typically we extract data, put it in a staging area and then load. Okay. So usage of that term, don't get confused by the terms data engineering or ETL. It is same. In data engineering, we use the terminology data pipelines. In ETL or ELT, extract, transform, load, extract, load, transform, we use the term ETL. Okay. So at a high level, I hope you understand what is data engineering, what is ETL. Okay. Let me now try to explain how ETL is written. We can assume a source system. And this is my destination, the warehouse where I want to put the data. You have to do data extraction. How do you do data extraction? I can do data extraction using Python. I'm just giving an example. I can do data extraction using Python. You can take any programming tool where you connect to the source system and pull data. So basically, if you are writing a Python program, assume this source system is a database. So in a Python program, you will write a code. Step 1, to connect to the database. Step 2, using a select query, you will fire a query on the source system, some table you want to fetch data, and the query will return back a result set. The result set would be a list of rows, and that result set would actually get in the Python environment as a data frame. That is extract. What you can do now, having extracted. So here I'll just show because I'm using Python. So here let's call after extract you got a Python data frame. You can do data manipulation in Python data frame using Python pandas data frame. You can do transform. So the code is now doing transformation in the Python environment. So you get transform data frame, which is again the data is still in the Python environment. You can then push the transform data to a table in your data warehouse. That is load. Probably you are not using the Python pandas data frame. Your data is a big data. So instead of doing a Python pandas data frame, you may use PySpark. And you may have a PySpark data frame. You do some transformation and load, and you load data and push it in something called data lake. Conceptually things remain same. Conceptually things remain same. Okay. Or you may not be using Python. Once again, let's have some source system. You may have something called as say Pentaho Data Integration Services. Or you may have SQL Server Data Integration Services. Okay. These are tools which gives you a graphical user interface. Okay. So I'll just put a box to say any tool which gives you data integration services. It may be a Pentaho Data Integration Services. It is one of the popular data integration services using open source. Now here you may have the entire workflow. Typically you will have a workflow, some workflows happening. So basically Pentaho Data Integration Services will have a connector by which you will connect to the source system. Basically end of day you can connect using a JDBC, ODBC to a database. Even Pentaho Data Integration Services, you can plug in your Python code, you can have a R code. So any other programming language which it allows to be plugged in, you can have that. So end of day, the point once again remains, using whichever tool, you will have a connection to the source and you will do extract. This Pentaho first step would be your E, which will have a connector and doing the extract. Then it will have a workflow where you do transform, and the last step will again push the data to a data warehouse or a data lake. Conceptually, if you try to understand, You need to extract data from a source. You need to do transformation. Transformation, when we say transformation, this is where your business logic comes. Based upon your business requirement, you will decide what is the transformations you require. So in transformation step, you have the business logic. And finally, that data needs to be stored in the warehouse. Now, why does the need of staging comes up? Let's try to understand the requirement of a staging. I will assume we are doing the coding with Python, okay, because that becomes easy for me to explain. This is your source. Using a Python code, you are doing extract. So here, let me show Python, okay. And the data that is being extracted from source is a transaction master. Transaction, assume it is a savings account, current account, banks, savings account, current account, transaction table. Now, a bank will have a huge customer base. When a bank has a huge customer base, the savings account and the current account transactions, each day the number of transactions that happens would be in millions. Okay. So when you extract, will you do full data extract? When you extract, you need to think of whether you need to do full data extract or you will do incremental data extract. Typically, from a source where there is a huge number of records, you will always do incremental data extract. The data which you have extracted already, from there you will take the incremental. Okay, incremental. So you are doing incremental data. Now this data, when you do incremental data, it may so happen that there was a transaction ID 108691, some transaction ID which I am mentioning here, which was already extracted in your previous run. And when you had extracted that data in your previous run, you had done the transformation and you had done the loading, and that data was already pushed. This transaction ID was already pushed in your warehouse. However, after you had done the ETL in your previous run, there was a change made to this transaction ID. So when you are extracting again, because there was a modification to this transaction, it will again get extracted. Okay. Now, if you take that data, simply transform and load, probably what may happen, you will have two copies of this. So what we do when we do the extraction, we put this data in a staging area. And definitely while after extracting, if there's some transformation, we will do the transformation and put it in a staging area. So in staging area, we will have this record between, and this staging area will actually be, because if you are final, this one is a database, this will also be some database. So from here, you will see whether this record already exists here. If it exists, you will do update. For the identifiers which are matching between the staging and the corresponding warehouse table, you will do update. And for all other data points which are there in the staging but which are not already extracted and pushed in the warehouse, you will do insert. Second aspect, this transformation logic. Basically, transformation I already mentioned is business logic. The business logic. Now you have to think whether you want to write the business logic of transformation in Python environment, or you want to write the business logic in database. So if you want to write the business logic of doing necessary data transformation in database, then again you will require the staging area, because after doing extraction using Python, you will be simply pushing it into a staging area, do the transformation, and from transformation load it. So there are two main requirements why you require a staging area. One is a staging database may come into play because you may want to write the business logic. If you ask me where you should write the business logic transformation, I would prefer writing business logic transformation in tool like Python or PySpark. Why Python or PySpark? Because Python or PySpark are in-memory processing. Because they are in-memory processing, the transformation happens faster. If you just use Python for extracting, putting the data in staging, and then doing the transformations in the database, in that case, your transformation will run slow. Okay. So ideally, I would suggest if you are using Python for ETL or PySpark for ETL, do extract data, have the data in memory, do the necessary transformation, and then push data to staging area. Quite often you may have to put the data in a staging area. You may not be able to directly push the data in warehouse. Reason being, there would be certain identifiers which you may want to update, and there would be certain identifiers which you want to insert. Okay. So staging area would become very essential. And from staging area, you will be able to do update insert. And if you are using a warehouse, the code for writing this update insert would typically go in a stored procedure. Okay, that's how the ETL would happen. So if I can summarize with a neat flow, the flow would be, this is source, you will do extraction using Python code. So here you will, after doing a Python extraction, you will get a data frame. On this data frame, you will do the transformation, which will again be a Python code. You will get a new data frame. This you will push, basically load to a staging area. Typically, most of the time, staging would be our database. So I'm assuming source to be a DB, staging again to be a DB. So in a staging table, some staging table, you will be pushing the data. From staging, you will typically do update insert. That is one approach. Or you may do delete insert. That is another approach. Basically, identifier which is here, if that data is already inserted and that identifier is like a primary key, you may want to delete that from the warehouse table and then insert all of the record, or you want to update those records and then insert the remaining one. So both the approaches are okay. Either you go with a update insert or a delete insert. And this part of the code, typically if it is because we are using a database, and this will be a database warehouse, this part of the code, I would ideally, this is again a loading stage, I would write in a stored procedure. Why stored procedure? Stored procedure is pre-compiled and it is a native language of database. So it will run optimally, it will run faster. So that's how the design would be. Okay. Now, how do you do this is what I'm explaining with the entirely with the Python, because that is one of the most efficient way of doing ETL nowadays. And instead of Python, you can use PySpark. Typically in big data, we use PySpark. Why PySpark? Because it helps you distributed computing. Yeah. And if it's a PySpark, most of the time the database may be something like a distributed database like Greenplum. Okay. So depending upon your requirement, you may have the database. But I hope the conceptually you now understand the concept of ETL or the concept of data engineering. I hope all of these has been very clear. Now, the important question, when you do extract, full data extract or incremental? That's an important question. Now, when we talk of data extract, see, if we are trying to extract data, which is, say, a master file, a product master. Product master typically will be a small table. It will have 100 record, 200 record, 500 record, 1000 records. So if it's a product master, I would suggest full data extract. There's no point looking for which are the new one or two new product data that has been inserted, because the table will not change very frequently. In some businesses like e-commerce, the data might change very frequently in product master table, but in certain businesses like a banking, the data does not change. So you have to again see how frequently the data changes. And how big is the table. If the table is small and the frequency is not basically the change is not that frequent, and more important is that data is small, 100, 200, 500 records only, I suggest do full transform, and here you may do update insert. Any existing record you may do update, and if there is any new incremental record, you simply do insert. Okay, so that's how. However, if it is a transaction table, you cannot do full data extract. You have to do incremental data extract only. Because When it is a transaction data, the main table may have millions of records, and each day you may have thousands of new records being inserted. So you cannot extract full data from a transaction table. So you have to do always incremental. The moment you say I will do incremental data extract, the question is, how do we identify new records? Or how do we identify existing records which were modified? The thing is, if someone has designed the OLTP system properly, there are two things which will always be there. One is a auto increment primary key. Basically, when you have a transaction will have transaction ID 1, 2, 3, 4, 5, 6, 7, something. And as new transactions gets inserted, the ID, the transaction ID will automatically be the next sequential higher number. So that is auto increment primary key. The second important thing is, if someone has designed OLTP system properly, there will always be a column, some column which will say last modified date. So you have to be very watchful to see the table which you are extracting, does it have a auto increment primary key and does it have last modified date? Okay. So when you do the ETL, say assume you are doing the ETL for the first time. When you do the ETL for the first time, you have pulled data, you do the transformation, and you have loaded the data in a staging area. When you have loaded the data in a staging area, you should capture max transaction ID. You should have this information, and you should capture max last modified date. These two values you should store in some table which you may call as audit table. So in an audit table, you will store for the given transaction master table, the last transaction ID which you had extracted and the last modified date transaction till which you have extracted. This is the first time. Now when you do the second time, you should refer the audit table first. And you should get the information. What was the max transaction ID till which you extracted data from source in the previous run? And what was the max last modified date? So incremental extraction will have the criteria greater than max transaction ID, or you will have to put an or condition, or greater than max last modified date. Because it may so happen there is a transaction ID which is, say, transaction ID 3 which was already extracted in the previous run, but after that there was some modification. So you have to do incremental based on max transaction ID or the last modified date, both the criteria. This is typically how you do incremental data extract. Knowing this, now I'm giving example with respect to a transaction master table with the assumption that, hey, the person who has designed the OLTP system has considered the best practices. The scenario may always not remain the same. Okay. So depending upon the source from where you have to pull data, you will have to develop your own logic for incremental data extract. That is very important. Logic development of incremental data extract is essential. Otherwise, you will end up doing ETL, where you will keep pulling whole data every day. Okay. Let me just go through slides. ETL stands for extraction, transformation, loading. E, extract data from source, transform, and this is where you do the business logic. And load is simply you push the data in the warehouse. Static extract, capturing a snapshot of source data at a point in time. Incremental, capturing changes that have occurred since the last extract. The first ETL is a static extract, because when you start the ETL for the first time, you will pull all what is there in the source, right? The day when you commence the ETL, for the first time, you will have to pull whatever is available, and then incremental will start. You have to know what is the last modified date or the auto incremental ID row number. Full extract typically you will do for master tables, which are small tables. Okay. Now, when you do ETL, you should ideally extract only the fields which are relevant. A given table might have hundreds of columns. Typically, when you do ETL, you should extract only the relevant fields. However, nowadays with big data and data lake, many of the people have the concept: pull all the data, whatever data you have, and just dump it in the data lake. We will see what we can do about this data later on. I again repeat, nowadays many people have the thought, let us just extract anything and everything, whatever data is there, let's just extract and push it in the data lake. Later on, we will think what we can do of that data. I have a different style of thinking. If you don't know what you will be doing with that data, there's no point extracting it. At least you should have some visibility of how this data will be relevant to you later on. You should know, okay, this will be relevant this and this way at some later stage. If you don't see any relevance, then there is no point extracting those unwanted columns from the source table. Okay, because it will just uh, increase your daily data ETL process. It will unwantedly load your server. It will unwantedly occupy space. Nowadays, space, hard drive, these are not constrained. With big data processing capabilities, many people feel are not constrained. However, how much money an organization can keep investing in having big data, the Spark cluster, because for Spark cluster also you require number of machines which are part of the cluster. You require hard drive, you require RAM, processing capabilities. Those are resources, they don't come free. So my suggestion, extract only those data and the relevant fields from table. And if you don't know why you are extracting, then avoid. Okay. Do not implement any business logic or data transformation logic when you are extracting. When you're pulling data from a source, take the data as is. Do not do modification except for many minor changes. Okay, very minor changes you are doing, it's okay. However, you should not do any data transformation logic while extracting. Whenever you do any data changes, you should always create new column. The original source column, you should not transform. You should keep them as is. Avoid extracting data directly from source and pushing it into a warehouse. Always extract data from source, put it in a staging area. In staging, apply the business transformation and then push it in the warehouse or the lake. Ensure proper data types are used. Do not keep all columns as string. Use always right data type. Numeric columns to be numbers. Date column should be date. Wherever timestamp has to be stored, date time. Timestamp, do not just let it become date. If there is a original data has timestamp element, keep timestamp. And that will be very essential because last modified date will be with last modified date and time. Prioritize the sequence in which data has to be extracted. Always extract masters first, because masters will have all your primary key which will have corresponding foreign key relation with other tables. Always get master tables first, then get the customer master table, because customer will buy your products and services. So the customer, when he buys your product and services or opens an account, there will be corresponding primary key foreign key association. And the accounts is where you typically have transactions related to. So you need to prioritize the sequence in which you would extract the tables. Always perform unit testing to ensure that the extraction logic is correct and there is no data loss. And one more important point, which probably I have not mentioned here, naming convention. As you know, when you do ETL, your data would be coming from different sources. Now, when you are pulling data from multiple sources, in one of the source, the customer might have been given, the customer ID might have been written as cust ID. In another source, the customer ID might have been used the variable name as CID. End of day, you are doing extraction, you are doing transformation, and you are doing loading. In the warehouse, you should have only one naming convention. If it is customer ID, if you have said, okay, I will say customer ID column in all my table, cust ID, then from here, when you do extraction, after doing extraction transformation, you should ensure CID becomes cust ID, or while you are pushing it, if you are not changing at transformation stage, also okay. But finally, when you are pushing the data in the warehouse, you have to ensure that table design has cust ID and you map CID to cust ID. Consistent naming convention is must, because finally the warehouse is your design. OLTP, because OLTP, when you are pulling data from multiple sources, the source systems were designed by multiple peoples. One source system was designed by one company another source system. For example, the core banking system would have been designed by a particular company, and a CRM system would have been designed by another company. They having different naming convention is obvious, but the warehouse, the data lake is designed by you. In warehouse, in the data lake, you cannot have different naming convention. You have to bring that consistency. Okay, so consistent naming convention is very essential. Okay, this is the loading part. However, I have explained in extracting only. So how do you go about doing extraction? How do you write the ETL? I'm explaining the E part, extract part. Now, your there will be a scheduler. You would have written your code, which will, because typically when you write the code, you will schedule it to run on a certain periodicity. So when the code gets started, the first thing, the code should see in the audit table. You will have to maintain, you will have to design the audit table where you store information for this particular source. From this particular source, this particular table, when I extracted, what was the last extracted data, what was the date time, what was the last extracted row ID, last when the ETL executed the last time, and when it executed the last time, whether it was a success. So you need to store this. If the last execution was not a success, then you might have extracted data, but that data might not have gone in the warehouse, right? So those date times are of no use. For the last successful execution, you have to ensure you store that data in the some audit table. So when the next ETL cycle begins, the first thing you have to do is get this information of the last success run, the date till which data has already been executed for a given source, the row ID. Sometimes you may not have row ID, you may only have the modified date and so forth. Then you have to see whether the ETL has already executed. It may sometimes happen that I am running the ETL for today, say 202205 19th May. I am running this ETL today, and once again I am triggering the ETL. One was automated scheduled ETL which got triggered. Second, I am manually triggering the ETL. When I am triggering the ETL the second time on same day, I should see whether what was the last execution and whether the last execution was success. If the last execution was a success for a given date, I should simply break out. Why should my ETL run? So you need to, for that purpose, storing these execution date and success is important. If the ETL was not success for the given day, the ETL has to move forward, right? You need to truncate the staging table. The staging data will have data of the previous run. So you should ensure the staging tables are truncated. And then you go ahead and extract data from the source based on the incremental logic, last transaction date time, the row ID, and whatever data gets extracted, you have to push it in the staging area. This is how extraction logic is written. I hope the extraction logic from this workflow is very clear. I'll just pause here. You see the workflow extraction logic which I have explained, and I'm sure with this flowchart things would be amply clear to all of you. Staging area. So let's try to now understand. We already understood the importance of staging area. So I'm just summarizing the importance. It's a temporary area. As you can see in the previous slide, truncate. Before we get the incremental data and push it in the staging area, we truncate the previous ETL data from the staging area, right? So staging area is a temporary area. What is the purpose of using a staging area? The purpose of staging area is to gather data coming from different sources. Now sometimes you may have, this is a source one table, a particular table from source one, and you have this some other table from source. There are two different databases. You are putting this in a particular staging area, so this will go in one table and this goes in another table of the same staging. Here they were coming from two different databases. Now the S1 and S2 are getting in the same database. Because these two tables are in the same database, you can now do any SQL query between these two tables easily because they are in the same database. Earlier, S1 and S2 were in two different databases, so doing any data manipulation might be difficult because you will have to then work with cross database queries, which is really difficult. So staging area is also used when you are gathering data from multiple sources and then you want to apply some data transformation. Okay, I hope this point is also clear. Staging area is the area where you do data cleansing, data merging, data transformation, the business logic. It is the area where you do the data quality validation, and sometimes you create your own surrogate key. Okay, basically the source table may have some primary keys. So there is a say branch master, and the branch masters have say in the source table the codes like something like this. You do not want to use these primary key which is in the source as a branch master B001, 002, 003. In your warehouse, you want to use something which is say branch IDs you want to use as 1, 2, 3 because querying with numbers is easy. So what you are doing is B001, you are giving your own different identifier which you are mapping it to 1. This you are mapping it to 2. This you are mapping it to 3 something. That is called a surrogate key. You giving your own different value for the primary key is called surrogate key. There are many reasons for giving surrogate key, creating our own surrogate keys. I have given one simple example of why you may want to create a surrogate key. Here in the source, the branch master, the primary key values are strings, and querying joining data with string is time consuming as compared to joining with numeric identifiers. As such, you give your own surrogate key. Okay, this is a simple example. There are other reasons for using surrogate key, and that is something called as slowly changing dimensions. That's slightly more in-depth concept of slowly changing dimensions. As such, I will not go at this point of time in slowly changing dimension. However, I hope you got the point. The staging area is also used when you want to give your own surrogate or primary key. Okay. Some typical ETL design related questions. What should be the structure of the staging area? Should it be a replica of the source system? Should staging area be created on same database instance in which the warehouse structure will be created? Is there a need to create a surrogate key? So there are many design related questions you may have. Typically, when I have worked in a warehouse, I have preferred to have the staging in the same instance of the database, and I try to differentiate between the staging tables and the warehouse tables by simply prefixing st underscore to all the tables which are staging tables. Okay. The benefit of having the staging tables in the same instance is you can do querying easily. That helps the querying purpose. Okay, because the tables are in the same instance, you can quickly refer and do querying between two tables which are in the same instance of the database. So that becomes very handy and easy. So from that standpoint, I prefer having staging in the same instance, same database instance, rather than having staging in a different database and warehouse tables in a different instance. Okay. So let me just explain the ETL with respect to a transaction table. A typical transaction table will have many columns. I've just showed a few columns from a transaction table: transaction ID, date, narration, debit, credit, amount, and so forth. And transaction ID is a auto incremental identifier, primary key. And the table may have 10 million, 100 million, huge number of records. And every day some 200,000 incremental transactions gets added, right? And typically the ETL in the banks, and not just banks, as I mentioned, ETL happens for most of the companies, most of the industries. ETL happens as a end of day process. What it means is at midnight, the IT department would take a full backup of daily backup incremental. There's an incremental backup that happens automatically, that keeps happening automatically, and end of day the IT department may also do a full backup, and you will be given access to a backup server. Typically you don't do ETL also from a OLTP directly from a OLTP server. Also you will be given access to a backup server, because OLTP system has to be made available to your end customers who are doing transactions, and they should not face any glitches. Because if you are running queries on your main production system, which is used for recording all transactions done by customers, if you do ETL from that system, it will put a load on it. So what happens is, in a bank, in any of these industries, end of day a full backup would happen, and you will get access to a backup server, and from backup server you will be doing ETL. So you need to find out the columns which will be useful for you for ETL, right? So if I ask you the question based upon the discussion so far, how will you design the ETL? How will you design your data extraction which runs daily in an automated and scheduled way for the transaction table? If you're watching this video, I want you to note down and put your thought process on a piece of paper. I want you to make a flow chart. How would you do the extraction part for a transaction table which is shown in front of you, where the ETL has to be done on a daily basis? Quickly do it. Pause the video. If you're watching this video online, pause the video, go back. You may want to go back and see this slide. So I am moving back so that this slide where incremental extraction logic is given and this slide where the sample transaction data is given. I want you to create a flow chart. Okay. Here on this screen, I'm just showing a sample audit table which I have for my own project, where I extract data from various stock exchanges, National Stock Exchange, Bombay Stock Exchange, and so forth. So here you see, whenever from a given source, if a ETL is executed, the information of when the ETL started, what was the start date, end date, and when it was last updated. So start and end date tells you from which date onwards the incremental data was pulled until when the incremental data has been extracted. Now here the source system gives you data on a daily incremental basis and there is no timestamp. As such, I have not mentioned and maintained any timestamp. But in a transaction table, when you have a banking transaction table, the transaction tables will have timestamp. Again, here there is no concept of incremental row ID because I'm doing a web scraping. So I have to go and see on the exchange. I had pulled data till 19th May 2022. Today, if I run it at the end of day, midnight, I will need the data of 20th May. So I need to pull data incremental of 20th May. So this kind of audit table has to be maintained for each given source. You need to give your source basically a tag, a task name. And based on that task name, you will have to maintain your ETL. For this particular source, I have given a source name or a tag. And here, whenever I do the next incremental ETL for the row number 13, if I have to now pull bhav copy information from NSE or I have to pull bhav copy information from BSE, I know I have data till 19th May in my system. The incremental data has to be pulled ahead of 19, and when that incremental extraction will happen, automatically the end date will get populated till where you have the data. This kind of audit table, depending upon your purpose, the business for which you are solving the problem, you will have to design. Secondly, you will have to also have a separate table. This table source audit gives you a summary for the given source. However, when each time you execute the code, it will be a separate execution, right? You need to keep track of each execution also. So when the data was extracted, so here you need to keep tracking, okay, this particular source, it the ETL started at this date with timestamp, it ended on this date with the given timestamp, and total time it took. Why total time it took is important? When you build a ETL system, as you keep adding more and more source systems for your ETL, and as you keep writing more and more business logic, at some point in time you will see that the total time for ETL may take, say, 2 hours. Now in that 2 hours you are not extracting only one table, you are extracting many tables from various sources, you are applying many business transformations and pushing that data in your warehouse or in your data lake. It was taking 2 hours, all of a sudden that 2 hours has started to become 3 hours, 2 hours has started to become 4 hours. Why is that time increased? If you have to debug, you will be able to debug only when for each and every task execution you have a information available how much time it took for that piece of code to execute. And based on that analysis, you can find which piece of your code is taking more time, that will help you optimize, where that will help you focus and pinpoint the problem area which needs to be further optimized. So these are important things. Whenever you do ETL, you have to keep track of given source, till which date time your data has been extracted, and you also need to keep track of each execution, whenever it starts, what time it ends, and how much time it took for that execution to process. Okay, so here I have maintained two things. One is at a source level audit, which I'm showing here, at a task level audit, which I'm showing in the other table. And here you can see there are lots of tables which I have in my design. There are many data which I'm extracting and doing ETL for my own stock market deep dive analysis. Okay. Yeah. And somewhere I have followed this ST convention also. Any data which comes first, it goes in a staging table. So it just tells you these are staging tables, and some temporary data transformations which are going in uh, the transformation tables and so forth. So you may have to follow some naming convention for your own purpose. Yeah, but this is just to give you overview. The main part is the audit, source audit and task level audit is very essential whenever you do ETL work. So coming back, I hope you would have got a good picture of, and you would have been able to make your own flow chart of how you design your ETL, E part, extract part. Now here I've just said, whenever you do the ETL, you need to ensure that the last transaction date and the last transaction ID, these two information should go in your audit table. And whenever you do extraction, your code will be select star, select whichever fields you want from the transaction table, where transaction ID is greater than this reference ID, which means before you can fire this query, you will have to go to the source audit table. For a given source, you will have to find out what was the last transaction date time data which you executed, what is the last transaction ID till which you have extracted. Those information you need to pull and then have the where clause. right? The next step after extraction is transformation. Transformation is where you will apply all your business logic transformations. Okay, from a querying or from a programming standpoint, the transformations would involve running joins, aggregations, creating surrogate keys, transpose, pivot, and so forth. So there are many different kinds of transformations which are specific to your business you will have to apply. And after you have done the transformation, the next stage will come as loading. Now when you do data loading and when you do data transformation, one of the important concept that is the granularity. For example, when you have transaction data, what is your reporting requirement? See, a transaction data would have data which is something like this, which is at timestamp level. Now, as a business user, say a branch or a product owner or a channel owner, what is the granularity at which they want to see the report? Is the branch interested in seeing report at hourly level, or is the branch manager interested seeing the report at daily level? When I say at daily level, what I mean is I want to see report at how many number of customers I acquired on a given day. And when I say hourly level, I mean how many number of customers I acquired on a given day at a given hour, in a given hour. Typically, you won't want report at hourly level. Most of the reports you don't want at hourly levels. There may be some specific scenario where you may want to track things at hour and minute. However, most of the business MIS are at daily, monthly, quarterly, and annual. So you need to understand the granularity at which you want information. According to that, you will have to decide your data aggregations. Once again, I would like to stress the transformations, the business logic, all are part of your business decisions. Okay. As part of my training, I cannot upfront say that, hey, you should do all the transformations at daily or monthly level only. So the question to be asked, what is the lowest granularity at which you want information? Because once you have decided the lowest granularity, accordingly you will have to keep storing the data. And if your lowest granularity is daily, you need to ensure all data is stored at daily level. Now, in a given data which is at daily level, then you may have to do some summarization, aggregations. And because I want report at a daily granularity level, I need to do aggregations at a day level. Okay, so these are the things which will impact the transformation. Aggregate the data depending upon the granularity and business requirement, and according to that aggregations you will create your data marts. I'll explain here one of the requirement which I had come across. Sorry. Yeah. So quite often the requirements are that you would require information which is for the day. Assume I'm a product manager, and as a product manager I would like to see report for the day. Basically standing today, I will want to see how many customers acquired yesterday. So how many customers acquired for the day. If I'm seeing the report today, that today's day is not yet completed. So I would mean for the day is yesterday only, right? I would like to see how many customers acquired month till date. And I would require how many customers acquired month on month. Now, when I am on say 18th of May, 20th of May, 23rd of May, the month of May is not yet completed. So it will be month till date. But when I am in the month of May, the April month, the March month, the February month is completed. So that is month on month, right? I would also require a report which is quarter. I would also require a report which is yearly. So in the year, okay. And when you have a calendar year or a financial year, you will have certain quarters which are completed and certain quarters which are running quarters. So when you have running quarter, it becomes quarter till date. When you have a year which is completely over, you will have full year information. And again, when you have a year which is running, you will have a year till date. So your one level of granularity is what happened for the day, that is yesterday, and then you have month till date, which is month on month, and so forth. So if I want this information, I can have a ID, and then you will have to be innovative that you give some naming conventions, some coding conventions, where you may say, okay, hey, some numbers, typically you have these numbers are month on month. So month, any month you will represent by mm. Okay. You can do aggregations easily for month data and get this information. A running month till date also, you can do aggregation and store information in this format. So this is a very easy ask to solve because this is a monthly granularity. However, there are certain reports which you require at quarterly granularity also. You, in that case, you will have to think of some naming conventions or ID conventions by which you can store this information, or you may have to create a completely separate data mart. Okay, so how can you solve this problem? From the account master table, where whenever a customer buys a product, for that product a account would be opened. So this is your account master, and this is available in your warehouse. I am trying to explain transformation part. We are in transformation part, and whenever a customer opens it, there will be open date. Now from a open date you can come to know this account was opened in which month. So if you simply aggregate the data based on open date at YYYMM level, you can say how many accounts were opened in a given year month. That is a smaller ask, 2022-01, and you aggregate and you store information hash accounts and you populate 100 or 1000, then 2022-02 500, 2022-03 700 something. So we have solved this problem. Now how do we get yearly and quarterly information? Yearly and quarterly information can be easily found if you can aggregate this data further. It will become quarter one. If you take the next three, it will become quarter two, assuming I'm going with a calendar year, right? So that way, from the monthly data, you can get the quarterly information. Similarly, if you take all the months which are belonging to a particular calendar year, 2021 01, 2021 02, and you can aggregate that data and you can get yearly. So what you have to understand, from month I can get quarter, from quarter I can get year. Okay, so hierarchy comes into play. If you understand hierarchy concept, then by knowing lowest granularity in the hierarchy, you can aggregate data and get any level of aggregated information. So that's where understanding the lowest granularity at which you would like to store data is very essential. Now the only challenge which is left is for the day. There is a special ask that, hey, I should also have report which gives me for the day information. Now, if for the day information, you cannot now make it 2022-01 something something. So what you can do is you give some special number that whenever you will do for the day, you will just give some this information. You will store it like this. 999,001 something, you think of your own logic, because it represents a year and month component. You think of your own number. Each time, each passing day, when you do aggregation, you delete this 99901 and insert 99901. So this way, the for the day information can also be aggregated and stored. Okay. So what is the most important thing which drove me and made me come here? Aggregate and roll up data depending on business requirement and populate them in the data mart. So for whom we were creating the data mart, I'll once again go to the next slide. We were creating the data mart for product manager. What is the requirement of product manager? One, he wants to see monthly trend. Monthly trend is very clear. You aggregate the acquired customers based on the account open date by taking their year month component. You aggregate and just put it in a mart, which is product mart. So here you will have this year month and number of customers acquired in that month. What is also second information, that months which are not completed, you want month till date. Now this month till date information will keep changing. Okay, this information each passing day, the number of customers acquired will keep increasing. So for that particular ID, whichever that month is, running month, say the running month is, each time you aggregate the data, you have to delete this and update or insert the data again. That's how you will get the month till date information. So this is not an issue. You require quarterly trend. Quarterly trend is very simple. You just aggregate Jan, Feb, March, it becomes quarter one. April, May, June, it becomes quarter two, like that. So quarter data can be extracted from monthly data. Annual data can be extracted from monthly data. So the lowest granularity is month in this case. However, this is Mart. The Mart will have the aggregated information. The account master table, which is being extracted from source, this data has to be at daily level. Why? Because you are aggregating data from here and populating in the Mart. An account master pertains to each and every individual. So individual level information will be stored here. Extracting data from source is one challenge. The transformations that you have to apply is a second level challenge, and it is a function of the business requirements and what is the reporting frequency, at what granularity the business users want the information. According to that, your transformation logic will be written, and according to that, loading will happen in the Mart. Okay. So if I have to put transformation and loading aspect, ETL we completed from the E part. This is from staging. You will apply the transformation and loading of data in the warehouse. And from data warehouse, you will apply certain more further aggregations to populate the data mart. The raw data will go here. Once it comes in the warehouse, you will have further aggregations to populate the mart. Okay, you do not apply aggregations on the staging unless there is a requirement, because quite often many of the aggregations that you apply will require not just the incremental data but also the historical data. So the approach would be, this is source, you do the extract, you put it in the staging area. There are certain new variables to be created which you will apply as transformations, and that transformations again you may put it in another staging table only, and from that staging area you will load and you will push data in warehouse. Then on warehouse you will apply certain aggregations, and these aggregations will again push the data in warehouse. There will be certain tables which are data mart tables. Data marts are basically aggregated. So you will apply aggregations and push back in the same data warehouse where will the aggregations being residing. Okay. So that's what we are trying to show. From staging, you do transformations and load the data in the warehouse. From warehouse, you further do certain aggregations which are specific for report generation. Okay. And you will set in your audit table that the audit tables will be updated that, hey, data has been successfully loaded in the warehouse. You do not update the audit table unless the data has been successfully pushed in the warehouse. In the E part, in the extraction stage, let me remove the animation from here. Just if you see the extraction part, after you have put the data in staging area, you don't update the audit table. Reason is data has still come only in the staging area. It has not completely resided in the warehouse. So from staging, you do transformation, push data in warehouse, you do the necessary data updation in the mart. Once all of this is completed, you will update the audit table saying, okay, the extraction from source to warehouse is completed. As I was discussing that you have requirements that you require month on month trend. You may see, is the date a month end? For example, when I am on 1st June, I will get data for 31st May, and 31st May is a month end. If the data which I am extracting is of 31st May, it will say, okay, hey, it's a month end. You may want certain month end related aggregations to happen. If it is not month end, because it's a daily thing, you will populate the data mart with a daily ETL. And if it's not month end, you will just break out, you will exit. But if it is a month end, you want certain month end reports also. So month end aggregation snapshots has to be created. So you may have certain more logic. Again, As you do month end, you may see whether it is year end. If it is year end, you may have some specific steps which are to be executed when it is a year end. You will execute those year end. Now, thing is, please understand, when you are designing your ETL, you have to design the ETL such that the code runs flawlessly and it runs automatically. Your ETL code should not be such that if it is a month end, I will manually sit and run month end code. If it is year end, then certain year end aggregations which I have to do, I will manually sit and then run year end steps. If you are writing your ETL only to manage daily incremental ETL, and you are not handling certain specific aggregations that you may want to do for month end, and certain specific aggregations that you want to do for year end, if you are not handling those specific scenarios, in that case, you are inducing manual intervention. Manual intervention is not good for any ETL design. Manual intervention should only happen because of certain reasons. Your logic did not work, your code failed, as a result you did not get the desired output, or manual intervention should happen only when there is some change in business logic, additional fields to be created. Only for those purpose manual intervention should happen. Otherwise, the ETL design should be such that the code runs automatically on a daily basis. There is a audit logs. The audit log should capture when ETL started, what data it has pulled from the source, till which date time it has pulled, what all aggregation, what all tasks got executed, when the task started, when the task completed, how much time it took for task execution. It should give you indicators of success or failure of your task and how much time it took to execute the task, so you can do further optimization of those. That's how the ETL should be designed. Okay. How you have successfully extracted, assume from the previous thing, the transaction data. How will you load the data from staging to warehouse? The logic of moving data from staging to warehouse should be update insert. Why update insert? I already mentioned a given transaction ID you have already pushed in the warehouse. If that data again is extracted, in that case you need to update. You need to probably, either there are two combination, update insert combination or delete insert. What is update insert? This data, this particular ID which is in staging, you should update the information for this particular ID in the warehouse. So that will become first step. All other IDs which are not there in the warehouse should be inserted. The other thing is, this record is already there in the warehouse and again it got extracted in staging. So from warehouse you delete this record. Now all the information which is there in staging you simply insert. So typically the logic of moving data from staging to warehouse will be update insert or delete insert. Okay. So here I am giving the query. So here what you assume is, in the staging table, that name of the staging transaction table is ST transaction, and the name of the data warehouse transaction table is data warehouse DW transaction. So the query, SQL query would be insert into the data warehouse table, and here you see select from staging where transaction ID is not present in the data warehouse. So the query is insert into data warehouse. What you have to insert? Select, simply I'll put it, rather than putting all columns, select star from staging where the ID of staging is not present in select ID from data warehouse. So I'm inserting only those record into data warehouse from staging which have already not been pushed into it. Rest of them, if the transaction ID already exists, you will do update. Okay, so that will be the insert update way of adding the data. So I hope these two flowcharts, this one, let me have these two flowcharts together now. This part, this is E extraction, and this is transformation and loading. This helps you understand how you should be designing your ETL. Great. I hope I have tried to do justice to explain ETL at depth. And with this, we conclude the session on ETL. Thank you. See you in some other video sessions where I would try to probably explain the ETL code of how I have written the ETL for extracting data from various stock exchange, and how I am managing my source audit table and the task audit table, and what are the various business transformations which I am doing as I move data from source to staging to warehouse. Thank you. See you, and kindly do subscribe to our channel on YouTube. Bye bye.